In this video, I would like to discuss the 3 questions that we reviewed today at the end of the class, and some of you said that they're still confused. So the first question was about a survey of families living in a certain city that was conducted to collect information on the following variables: age of the oldest person in the family, number of family members, number of males in the family, number of females in the family, whether or not they own a house, income of the family, whether or not the family took vacation during the past 1 year, whether or not they are happy with their financial situation, and the last one is the amount of their monthly mortgage or rent. So just going to change this one a little bit. Something doesn't work for this one. So the idea is to separate them in 2 categories first: qualitative variables and quantitative variables. So we said that the qualitative variables are about labels, categories, opinions. So the ones that I underline in green are the qualitative variables: whether or not they own a house, whether or not the family took vacations during the past 1 year, whether or not they are happy with their financial situation. So these 3 variables are qualitative variables. Now, quantitative variables, they're connected to numbers. So age of the oldest person, number of family members, number of males, number of females, income of the family, as well as the amount of their monthly mortgage or rent. So the red ones are quantitative variables. The question also has a second part where it asks which of the quantitative variables in part B are discrete variables and which are continuous variables. So we discussed this one in class when the variable answers the questions how many, when we can count, it is discrete. So the number of family members is discrete. The number of males in the family is discrete. The number of females in the family is also a discrete variable because we can count them. We can ask the question how many. The continuous one, we need to ask the question how much, and they are about the length of time, the period of time. It could be weight, it could be height. So we have age of the oldest person, how old the person is. We also have income of the family, how much. We ask the question how much. And amount of the monthly rent or mortgage, again, is the quantitative continuous variable. They answer the question how much. How much do you have to pay for your rent? How much did you get paid this week? So you can see that the continuous variables, they are not only whole numbers. We cannot just count them. We have a decimal option here as well. So this was for question 1. Question 2 is we had 20 numbers. I counted them and I ordered them because you witnessed this one in class, it takes time to order them from least to greatest. So I told you that the classes, they need to be given in the question. So you need to write the numbers from least to greatest. If you have numbers that repeat, you need to write that one as well. So how to find the class width, how wide each interval is. So if you remember the class width, let me change this, okay? The class width was maximum number minus the minimum number, and we need to divide this by the number of classes. In our case, the number of classes is 3. So let's do this. So this will be 31 minus 2, and we have to divide this by 3 because in the question is asking for 3 classes. So 29 divided by 3, it's going to be a number close to 10. 9.6, 9.7. We rounding up. Even though if it was 9.1, we must round up here. So let me write this one, round up. Always. For this one, for the class width. So in this case, our class width is 10. Now we're ready to set our intervals. So for the intervals, we need the lower limit, upper limit, and the frequency. Lower limit, upper limit, and frequencies. Okay. So if we separate them, go here, maybe we can decide to do a little bit more. So the first lower limit is always the minimum number that we have, which is now, in our case, it's 2. So we have 2. So the reason why we were looking for the class width is because we're adding the class width to the lower limit, to the first lower limit, to get the next lower limit. So what we're doing here is we're adding 10. So the next lower limit is 12. And since we want 3 classes, which means that we want 3 bars, we're adding another 10. This is 20. Now, since we know the lower limit for the next interval, we need to go 1 back. So the upper limit for the first interval will be 11. And we can apply the plus 10 rule again. That will be 21. And another plus 10, because that's the class width, that will be 31. Now, we need to count the frequency for each interval. So let's see, between 2 and 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. Between 12 and 21, we have only 2, 18 and 21. And the last numbers between 22 and 31, we have only 4, 22, 27, 28, and 31. So this is 4. Now, we have enough information for the histogram, but if we decide to go a little bit further and find the relative frequency and the percentage, we can do that. I didn't leave much space, but I think I will manage. So if we want the relative frequency, and if we want the percent, So the relative frequency, as I said in the beginning, there are 20 numbers. The list that we have 20 numbers. How are we going to find the relative frequency? We're going to divide the frequency for each interval. So in this case, 14 divided by 20. It should be 0.7 or 0.70. Then we have 2 divided by 20. That's 0.10. Then we have 4 divided by 20. So this will give us 0.2 or 0.20. And you can see that if we multiply this times 100, we're going to have 70%, 10%, 20%. And we also discussed this one in class that we will have 100% at the end. If we did our calculations correctly, our percentages should add up to 100. Now we're ready to graph. We're ready to graph frequency distribution or histogram. So we're gonna have our graph here. So we have from 2 to 11. The first interval was between 2 and 11. The next one is between 12 and 21. And the last one was between 22 and 31. Now, since we have the 14 was the highest, we'll go by 2. 2, 4, 6, 8, 10, 12, and then 14. So this is our frequency here. Perfect. All right, so what we're gonna do is we're gonna build our bars. Okay, 14. Okay, perfect. Then the next one was only 2, so it's a small one. Okay. And the last one was 4. Okay. Okay, perfect. So again, we have 14 between 2 and 11. We have 2 between 12 and 21. And we have 4 between 22 and 31. Now, since we want the histogram, this is the bar graph. Since we want the histogram, we said that we need to melt the gap between the bars by adding 0.5 and subtracting 0.5. So if we subtract 0.5 from 2, we'll get 1.5. Actually, I'm going to use a different color for this. Okay. If this will be 1.5 because we taking away 0.5. If we add 0.5 to 11, so this will be 11.5. And the same thing is going to happen if we apologize for this one. It's back. The same thing is gonna happen if you subtract 0.5 from 12 and you add 0.5. So this will be 21.5. Adding, subtracting. And the last thing, you're gonna add 0.5 to the last upper limit. That will be 31.5. Now we can just build the histogram. I will use different color for this one as well. So we're gonna start from 1.5. Okay. Then we have this, and we have right here, they meet in the middle. Now we're gonna connect this. Perfect. Another extension here with 0.5, and then we're gonna okay. Okay, it doesn't matter. Just gonna pretend. Okay, somehow it happened. And this is the last one. Perfect. So this is our histogram. This is our histogram. So what we can see from our histogram is that most of the numbers are between 2 and 11, and we have less numbers between 12 and 31. So this is how we do our histogram for the second question. Again, you must order the numbers from least to greatest. The number of classes is always given, and you have to find the class width by subtracting the bigger minus the smaller number in the data set and divide by the number of classes. And you always round up for the class width. Your first lower limit is the minimum number. And how you're going to use the 10 is you adding the class width to the first lower limit to get the next lower limit. And then you need to go one back in order to find the upper limit for the first interval. So 2 to 11, 12 to 21, and 22 to 31. And you can see that we can add the 10 to the upper limit as well, because the class width stays the same. And we count how many numbers we have from our data set between 2 and 11, and 12 and 21, and 22, 31. And then we just plot the histogram. Now, the last question was about box and whisker plot. Now, if you want to do it manually, you need to order them from least to greatest. So we have 24 numbers. This will take some time. I will do it on the calculator because the calculator will help me to calculate it faster. For the calculator, you don't need to enter them in order. They don't have to be in order. So let's go to the calculator and enter the 24 numbers. By the way, I did this one in advance. Let me see if it's sharing. Okay. Okay. So this is the calculator. How we entering the data? We need to go to Stat, Edit. We press Enter. As I said, I entered my numbers. They are not in order. I just took them the way I saw them in the question, 23, 37, 26, 19, and go on. So there are 24 questions. 24 scores, I'm sorry. I enter all of them. So now we need to find the 5-number summary statistics for this data. So how we do that? Here you go, I have 24 numbers. We're going back to stat calc. We're gonna do stat calc, one variable, and we're gonna press enter. Now, the calculator is telling us that the scores are in L1, and that is correct. So we're confirming and continue. Don't put anything in the frequency list, and then we have calculate. Okay, so we're gonna scroll down because we are interested for the box and whisker plot. We are interested in the last 5 numbers of the variable statistics. So I'm gonna write the numbers here, and you'll see how we're gonna use them. So minimum will be 8. Quartile 1 is 23.5. Quartile 2, which is also the median, okay, so that's the 50%, is 28.5. Okay, quartile 3, which is 75th percentile, 36. And maximum is the highest number in the data set is 64. Okay, so since we want to do the box and whisker plot, here you go, my numbers are here. We in class we talk about the upper fence and the lower fence, so we can see if there are outliers. So the formula for the outliers, guys, was you need to find the interquartile range first, which is the difference between Q3 minus Q1. In our case is 36 minus 23.5. Okay, so 36 minus 23.5, let's see, 36 minus 23.5, 12.5. So this is the difference between the Q3 and Q1. Now, the rule says it's always 1.5, so you need to find the product. Find the product. 1.5 times the interquartile range. And let's see it. 1.5 times 12.5. Let's see what this will give us. 18.75. Now, what we're going to do with this number is, in order to find the lower fence, we're going to subtract this one from the quartile 1. And in order to find the upper fence, we're going to add this to quartile 3. So we're going to see if we have any outliers in this case. So we have a lower fence that will be quartile 1 minus 18.75, and the upper fence will be quartile 3 plus 18.75. So let's find it here. LF will be 23.5 minus 18.75, and the upper fence will be 36 plus 18.75. Okay, let's find these two numbers. Four 0.75, and let's see the other one, 36 plus 18.75, 54.75. Okay, so it means that if we have a number that is below 4.75 and above 54.75, we can consider them outliers. So how would we use minimum, Q1, Q2, Q3, and maximum? So this is what we're writing. Here is our box and whisker plot. Let me write these numbers down. Okay, so minimum, let me write what we're doing. We're doing the box and whisker plot. So we're starting with the minimum. Okay. Okay. Okay, and we have to go to the maximum. Okay, so the minimum is 8, the maximum is 64. So the middle one, the median was 20.5, which is definitely closer to 8. So it's going to be in this way here. 28.5. This is Q2, or the median. This is Q1 right here, and this is Q3. So this one was 36, and this is 28.5. We have 36 and 23.5. Now I'll use this one for upper and lower fence. So 4.75 is somewhere here. The lower fence is somewhere here. That's 4.75, which is good. There are no outliers on the left side. Now here, the upper fence is 54, somewhere here, upper fence is 54.75. So it looks like 64 is an outlier. 64 is an outlier. Prepare this data visit. Okay, so in this case, 64 is going to be an outlier, and also we need to see how, if the we didn't talk about the skewness of this data, but we can I can show you what is the idea of this one. Let me see. Okay, so 64. Okay, I didn't finish this one. Outlier. So 64 is an outlier. And the skewness, we'll talk a little bit in class, but this one should be skewed to the right, because when you have that, we talked today about bell shape, but this one is not going to be exactly bell shape. It's going to have more numbers here, and then it's kind of going to go like this. So next time when we talk about the shape, this will be skewed to the right. We have more numbers. So these were the 3 questions that we discussed today, and I hope the video was helpful. I'm sorry if it's a little bit long. I just wanted to go slow so you can see the steps, and I will see you again in class. Bye.